Hey y'all, so let's cover the review for exam 3. And this is, remember, you can use both sides of one 3x5 note card. Prepare it before your exam. Feel free to use examples. Sometimes that helps instead of using A, B, C. For the problems below, the answers are on the second page. Do not look at the answers until you've completed the problems. This is to make sure you're ready for the exam. I also don't want you watching this video until you've attempted it by yourself. So the goal here is to study for math. You need to take the review like you're taking the exam, only with your 3x5 note card, and get through as much as you can. Once you're done with that, anything you couldn't do, go back and use your notes and do as much as you can then. Whatever you had to use for your notes, make sure you're providing that for yourself on your note card. Also, go back and work on the problems in the homework and mom to make sure you're understanding the material. Okay. So let me know also if you have any questions after watching the video. This video should only be used after you've exhausted all of your trials on attempting this and you're just so flustered you're like, okay, somebody's going to die. So let me see if I can help you out. There's only 10 problems here. It's a short test, but these problems are a little intense, so I want to make sure that you're comfortable. Starting with number 1, xy plus 3x minus 5y minus 15. So anytime you have 4 terms, you always want to look at them as 2 and 2. Look at the first 2 only. What do they have in common? What can we factor out? They both have an x. So I'm going to factor out an x. When I factor out an x for my first term, I'm left with y. Plus, when I factor out a term, x for my second term, I'm left with a 3. Looking at the next 2, my goal for the next 2 is I want to be able to factor something out that will leave me with y plus 3. I want it to look just like this binomial. So if I'm going to do this, I'm going to have to factor out a -5. And if you can double check yourself, -5 times y is -5y, -5 times 3 is -15. All right, now we're going to look at both of these. What do they have in common? They have y plus 3. When you factor out y plus 3 from your first term, you're left with x. When you factor out y plus 3 from your second term, you're left with -5. That is your factored form. All right, let's go to number 2. 2x to the 4th minus 2. First thing I do is, what do they have in common? This is the greatest common factor. What do they have in common that I can factor out? And they both have 2 in common. Factoring out a 2 from your first term, left with x to the 4th. Factoring out a 2 from your second term, you're left with -1, not 0. All right, now looking at this, I can see this binomial is what? This is a perfect square, and this is a perfect square. So this is the difference of 2 squares. So we know that the difference of 2 squares is equal to a minus b, a plus b. You can use numbers as well. You can use x squared minus 9 and do it that way, whatever is better for you. Bring your 2 down. The 2 does not disappear. And when we factor this, it becomes x squared minus 1 and x squared plus 1. All right. Well, this is another difference of 2 squares. So factoring it, we're left with x minus 1, x plus 1. Now the sum of 2 squares cannot be factored. It is prime. So you're just going to bring it down. That is the factored form. Number 3. 4x squared minus 28x plus 49. Do they have anything in common? Nope. 4 does not go into 49. It goes into 28, but not 49. So I'm just going to need to factor. Well, I've got a couple different things I can do here. I can do the AC method, or I could just, wait a minute. Wait a minute. This is a perfect square. 2 squared is 4. X squared is x squared. And 49, the square root of 49 is 7. So 7 squared is 49. So this is just a binomial squared. So it's 2x minus 7. it. You could have gone through and factored it. You would have gotten 2x minus 7. 2x minus 7 is two binomials. That's 2x minus 7 squared. Okay. Fantastic. I wasn't looking forward to that one. All right, 4, x cubed plus 8. This is the sum of two cubes. To help you see that, this is x cubed plus 2 cubed. This is the way I like to see it or look at it, because then when I go to fill in the formula for this, then I can just go, okay, well, this is just x plus 2. And then for your trinomial piece, you only look at this. It's x, you square the first one, minus, because this is plus, the middle term has to be minus, 2 times x is 2x, plus 2 squared is 4. And that is the factored form. Now, this is the sum of two trinomials. You also need to provide yourself the difference of two trinomials, because I could give you either one of those. Number 5 is 4x squared plus 8x minus 12. First thing I'm going to do here is I see that they're all divisible by 4. They're all even, so definitely 2. So then I check the next one. Is it 4? Well, yeah, it is. So I'm going to factor out a 4. And when I do that, I'm left with x squared plus 2x minus 3. That's much nicer. That's much nicer to factor. X and x, 3 and 1. Those are the only things it can be, because 3 only has factors of 3 and 1. So now we just need to make sure that the middle term is positive, and we're going to have a subtraction here somewhere. The middle term positive means that our larger term must be positive. When you check your OI, 3 times x is 3x. 1 times x is negative 1x, and that gives me 2x, which gives me exactly what I want. That is the factored form. Go to number 6. X squared plus 5x plus 7. X and x. Ooh. 7 and 1. That's not going to give me 5. That's not going to work. So I'm going to have to use the quadratic here. Yeah, I'm going to have to use the quadratic. And the quadratic is x equals negative b plus or minus the square root of b squared minus 4ac. All of that is over 2a. Where a is 1, b is 5, and c is 7. Now, I think I need to double check the exam. On the exam, I'm going to give you this. Okay, I'm going to give you this. That way, leave space for your 3x5 note card, but also so many students I find write it wrong, and I want to make sure you have it correct when you take the exam. So negative b, negative 5, plus or minus the square root of b squared, so 5 squared minus 4, a, c, all of that over 2 times a. Negative 5 plus or minus the square root of 25 minus 4 times 1 is 4. Well, negative 4 times 7 is negative 28 all over 2. Negative 5 plus or minus the square root of, well, this is negative 3 all over 2. So if you were to just write that this is prime or does not factor without getting to this point, you would get 1 point, because that's just a guess. You're not proving it. You have to prove that you understood why it was prime. Okay. The other thing is, those of you who are going on to college algebra trig or 1590, you need to understand that you need to be able to get to this point. This is very important, because we're going to take this and keep going in that class. You're not done at this point. This is not considered prime when you get to college algebra. We can keep going, and we will. All right, that is 6. So you're going to, for this one, you're going to call it prime or does not exist. Either one works, but you must show why. And that's with any of them. If you just give me an answer and do not prove it, it's 1 point if it's correct. Let's go to number 7. 2x cubed plus 19x squared plus 35x. Well, I can see they all have an x. 2 does not go into all of them. So we're left with 2x squared plus 19x plus 35. See if I can factor this. I would want to use the AC method here. 35 times 2 is 70. And I need to find out what two terms multiply to give me 70, but add up to give me 19. Well, 70 is made up of 7 and 10. 5 and, oh gosh. Oh, no. 70 divided by 5. Come on, Sandra. And 14. So 5 and 14. Well, there's my 19 right there. They add up to give me 19. 5 times 14 is 70, but they add up to give me 19. That's my winner chicken dinner. So how am I going to do this? I'm going to rewrite it with 2x squared plus, I'm just going to write it the other way. I think it'd be better to, well, no, I could do 5 plus 5x plus 14x plus 35. All right. Now I look at the first two terms. What do they have in common? They have an x. Let me do this. Leaves me with 2x plus 5. And then for these two terms, they have 7 in common. Leaves me with x plus 5. Oh, 2x plus 5. All right. Don't forget your x. Now, for looking at both of these sets of terms, they have 2x plus 5 in common. And when you factor 2x plus 5 from your first term, you're left with x. And when you factor 2x plus 5 from your second term, you're left with plus 7. And you could just rewrite this. And there is your answer. Number 8. 2x to the 5th minus 250x squared. They definitely have a 2 in common. And they have x squared in common. I don't know why I'm writing. All right, so this would leave me with x cubed minus 125, which are both perfect cubes. So that's the difference of two cubes, because this would be x cubed minus 5 cubed. I'm going to rewrite this as 2x cubed, x minus 5, just following the formula, squaring the first one, multiply them together, square the last one. Number 9. 9x squared plus 24xy plus 16y squared. The easiest way to do this is to multiply to do the AC method, it looks like, because there's nothing I can factor out. They have nothing in common. All right, so 16 times 9. Oh, wait a minute. I do this every stinking time, y'all. Every stinking time. I do this and I'm like, gosh, that just seems odd. 3 is a perfect square. X squared is a perfect square. 16 is a perfect square. And y squared is a perfect square. So that means all I have to do, everything's positive, is take the square root of the first, so 3x, the square root of the last, 4y, and put a cute little square on there. Booyah. Done. I could have made my life hard and did 3x plus 4y, 3x plus 4y. Doesn't sound fun to me. 24x squared plus 3xy minus 27y squared. Now, this is not the same case here. All right, do they have anything in common? Yes, they do. They all have 3 in common, and that's it. So 8x squared plus xy minus 9y squared. Still not perfect squares, but I can factor them. Do we want to, let's see here, 9 times 8 is 72. And I need the factors of 72 that give me 1. How are we going to do that? Let's do this a different way. Let's do the trial and error method on this one. Let's see if we can make this work. I don't even have the answers here for this. I can't do the sneaky sneak thing. All right, so let's try this. Now I'm going to do this. 72, the factors of 72 are what? I think this one's going to be harder to do it this way. Let's try this. So I'm going to try 4 and 2. Hold on just a minute. I want to think through this for a second without you having to sit here with me. So I'm really overthinking this. And I am going to be changing the answer on your answer key because I do see that this is wrong. 8 and 9, which multiply to give me 72, but are also the difference is 1, are going to have to be what I use. So here's what I'm going to check. I am going to do a little bit of trial and error here, piece. I'm going to try 8x and x, 9y and y, and I'm also going to check 8x, x, y, and 9y. It's got to be one of these two. All right, let's check this. So my OI here, my outer would be 72. That's going to be too big. And then y. So that one's not going to work. This one, my outer is 8x times y, which is 8x, and my inner is 9xy, and that works. And I want my middle term to be positive, so my y has to be positive. My 8 has to be, I'm sorry, my 9 has to be positive, my 8 has to be negative. So this is the final answer, and I will go change that right now on the answer key because that is, it's not fully factored. What the answer key did is it didn't have the 3 factored out, and you should always factor out your greatest common factor, period. Okay, so this is fully factored. All right, that is it. I'm going to go fix that answer key right now. Let me know what questions you have. Sorry about that little glip.